Let's review some of 12.7 experimental and theoretical probability notes. Example number 1. Dylan divided a spinner into 4 equal parts. He colored each part a different color, red, yellow, orange, and blue. He spun the spinner 20 times and recorded his results. He then performed this experiment 2 more times. The results are shown in the table below. First question, what is the experimental probability of spinning orange in the first experiment? In the first experiment, he received orange, or spinning of orange, 4 times out of a total of how many total times? Well, 7 plus 6 plus 4 plus 3 is 20 total times, and it told us in the directions that he spun the spinner 20 times. So this would be 4 out of 20, which then can simplify into 1/5, which is 20%. Question 2. What is the experimental probability of spinning orange in all 3 tests? So now we want to add up the 4 plus 6 plus 5, and that gives us 4 plus, wrong spot, 4 plus 6 plus 5 gives us 15 total times out of 60, because 20 for the first experiment, 20 for the second, and 20 for the third. So 15 out of 60 simplifies to 1/4, or 25%. All right, let's look at real-world example number 2, simulation. A medication is predicted to be effective 2 out of 3 times. Question 1, what could be used to simulate the effectiveness of the medication working? Explain. Well, one example could be you could use a die or dice where the numbers 1, 2, 3, and 4 represent the medication working, because 4 out of 6 would simplify to 2/3, which is what the effectiveness of this medication is. Part B, describe a simulation if the medication is predicted to be effective 3 out of 4 times. One way to simulate this is you could roll the dice once to simulate one person's chance of the medication working. Record the result, then repeat this 3 more times. Example 3. A multiple choice test has 5 questions. Each question has 3 possible answers, A, B, or C. Kelly would like to figure out the most likely mix of answers. Question 1. What objects can be used to model the possible outcomes of the answers? Well, each answer can be A, B, or C, so there are 3 to the 5th, or 243 possible outcomes for this test. Use a simulation that also has 3 outcomes for each of the 5 events. One possible simulation would be to place 3 slips of paper into a hat. One would be labeled A, one labeled B, and the last one labeled C. For each question, you would choose 1 slip of paper, record your answer, replace it, and continue to do this process again 5 times. Question B. Find the theoretical probability that there will be all A's. Well, there are 243 possible outcomes, and the number of combinations that all have A's is combination of 5 choose 5, or that is equal to 1. So the theoretical probability is 1 over 243. Again, it's a combination of 5 choose 5 because you want all 5 questions to have just one answer, which would be letter A. It doesn't matter the order you answer them, it just matters that they have an answer of A. Question C. The results of a simulation Kelly performed are shown in the table. What is the experimental probability that there will be 4 B's? If you add up the total trials over at the right, Kelly performed 50 total trials. And you can see I highlighted the 2 results that were shown with 4 B's, one with 1 A and one with 1 C. So the experimental probability that Kelly did here was 2 out of 50, which is 1 over 25, which is 4%. Part D says compare that to the theoretical probability of actually there being 4 B's. So the probability of getting 4 B's is a combination of 5 answers, and you want 4 of those to be answer B. You don't care which ones are B's, but you just care that there's 4 out of the 5 over the total outcomes, which is 243. Well, combination of 5 choose 4 is 5. There's only 5 ways out of 243. And that percentage is 2%, So the experimental probability that Kelly got of 4% versus the theoretical probability of 2% was that they are very close to each other. Thanks for listening to the notes with your group. Please go ahead and now work on the 12.7 word problem worksheet.